back to, once we get halfway through this chapter, and if you were to re-look back at this lesson, it would make a lot of sense, but it's trying to explain something and kind of where do you start. I promise you, halfway through the chapter, if you go back and look at this lesson, you're going to be like, wow, that's super easy, even though because it's so brand new right now, it may be a little bit confusing. But it will come together. So we're going to be drawing a lot of angles, and we're going to be drawing angles in standard position. So you have a XY axis, and if you are told to draw an angle of, let's go, 120 degrees, okay? Any angle is made up of two rays. Are we okay with that from geometry? Okay? So your initial ray, when you're drawing an angle in standard position, is always on the x-axis. So there's your initial ray. And if we are opening this to 120 degrees, you open in the counterclockwise direction. So you open up to approximately 120 degrees. And that would put you in the second quadrant. Okay, so I'll just label that 120 degrees. So this is called your initial ray. It will always be on the x-axis. And this is called your terminal ray, where it ends. Terminal ends. Okay, initial starts. Where your terminal ray ends, in which quadrant, is going to be a huge focal point for us. You always want to know where your terminal ray is. You always want to know what quadrant the angle is in. And this angle, technically I'm talking about the terminal ray of the angle, but this is a second quadrant angle because the terminal ray is in the second quadrant. Okay? Positive rotation, which is what I just gave you, positive 120, travels counterclockwise. If you have a negative angle, which seems like a foreign idea right now, but it won't, negative 120 would open in this direction, would open clockwise. So I mentioned that here, a negative rotation travels clockwise. Okay? Angles in trig are named using Greek letters. So you're going to hear a lot of theta. Alpha, which is this symbol, and beta. Those are the three most common ones. There are others, but those are the three that I think that the entire trig chapter pretty much sticks to. Okay? So this first section wants us to draw a rotation diagram for the following angles and then state the quadrant that the terminal ray falls. So your initial ray is always on the x-axis, so draw that. And then this is a theta of 140 degrees. Now, just for curiosity, how many degrees is this y-axis? 90 degrees. How many is this one? 180. How many is this one? 270. Okay, so 140 is obviously going to fall how many degrees shy of the 180? Right. So that's going to be 140 degrees. That's your theta. And so that's a Q2 angle. I'll just say Q2. Yep, Andrew. What does the initial ray? The initial ray always starts on the x-axis, headed to the right. The positive x-axis is always the initial ray. Okay? For B, same thing. Initial ray starts on the x-axis. Now we're opening up in the negative direction, so we're going to be opening up this way. So this is negative 90. This is negative 180. This is negative 270. So negative 300 is going to be in what quadrant? The first. You're going to wrap all the way around, and it's going to be right here. Negative 300 degrees, and that's your alpha. How many degrees shy of the x-axis is this? 60, correct. So that's like negative 300. So this would be negative 360. So it's 60 degrees shy of the x-axis. Very good. Do you see how, like, on this diagram, that's positive 180, but on this diagram, it's negative 180? A positive 180 degree angle and a negative 180 degree angle are the same terminal ray. Okay? Same thing here. This is 90, if you're thinking in the positive world. This is negative 270. 90 degrees has a terminal ray that's in the same exact location as negative 270's terminal ray. They coincide with each other. Okay, and we'll talk more about that. This last one is 450. What can you say about 450? 0, 90, 180, 270. What's this? Okay, 0 and 360 coincide. What's this? We got to go 90 degrees past 360. So 100 degrees past would be 460. So that's going to be actually 450 right on the nose. So your initial ray is still the x-axis. What you would say about 450, what I was looking for, is that it's over 360. It's one full circle and then some until your terminal ray ends right there. So if someone were to just show you this angle and not tell you the measure of it, some people would say it's a 90 degree angle. But guess what? It's also a 450 degree angle. And I could add 360 degrees onto that, and it would also be whatever that number is. Okay? Because we keep, winding this thing around in a circle, so eventually we overlap ourselves. Okay? And this one was a Q1 angle. This one is not in any quadrant. It's not in quadrant 1, and it's not in quadrant 2. It's between those quadrant, so that terminology is quadrantal, if it doesn't actually fall in a quadrant. Okay? So the angles I'm talking about here are coterminal. A 90 degree angle has the same terminal ray as a 450 degree angle. Those are called coterminal because their terminal rays coincide. I also kept asking you above about what's the angle between the terminal ray and the x-axis here. And you guys told me this was 140. So you told me that that was a 40 degree difference, right? That's called your reference angle. Reference equals 40 degrees. What was the angle between this terminal ray and the x-axis if this was 300? 60. So this reference angle was 60 degrees. What's the difference between, in part C, this terminal ray and the x-axis? And the x-axis. The terminal ray with the x-axis makes what angle? What'd you say? 90 degrees. Your reference angle has to be between 0 and 90. So let's say that. Reference has to be between 0 and 90. It's the angle made, and I already wrote it. So it's positive. There's between 0 and 90. It's acute, also between 0 and 90, formed by the terminal ray and the x-axis. And Andrew was tempted to say 0 here, and I know why, right, Andrew? Because it's right on the y-axis. But the reference angle has nothing to do with the y-axis. It's the angle between your terminal ray and the x-axis. So your terminal ray and your x-axis, and you could go either direction here, right, is 90 degrees. Okay? Coterminal angles like 90 and 450 just land on top of each other. So in order to come up with a coterminal, like 140 we know is here, you just really add 360 onto it, and it will land on itself. Or you could subtract 360. So just 140 plus 360 gives you a 500 degree angle. So that would be a coterminal. Nathan? Yes. Yep, exactly, because it has to be between 0 and 90. Which is why in this one we don't go back to this x-axis over here. We just pay attention to this side because we want the acute angle. Good question. Okay, negative 300. If you want to find a coterminal, just add 360 onto that. You'll get 60 degrees. Can't we all look up at example B and agree that this negative 300 degree angle would be the same as if they had us graph this? Positive 60 degrees. They have you open in the positive 60 degree direction. That's the same as opening in the negative 300 degree direction. They land on top of each other. And last one, 450, you could add on 360 or you could subtract 360. What that's doing is that's just spinning your terminal ray around in one full circle. So it's going to land in the same spot. 90 degrees. Okay, so some basic vocab that will come up a lot, and I can assure you it will be second nature pretty soon. Yes. Yep. Yep. There's multiple coterminal angles. There's an infinite number because you could add 360 as many times as you want, and it would be a version of coterminal. We already did A, B, and C for example 3. We already determined the references on the front. Let's just look at D real quick, and you're going to have to sketch these little pictures a lot. Here's your initial ray. Our theta is having us open in the negative direction 180 degrees. So here's our terminal ray. What is the reference angle here? What is the measure of the angle between this terminal ray and the x-axis? 0. Very good. 0 degree reference angle. That's the smallest reference angle you can have. So this next section is just for each of the following angles. We won't do all of these. Given by the Greek letter theta, draw a rotation diagram. Okay, so let's do part A. Here's your initial ray. We have 0, 90, and 180. So which quadrant is 145 going to fall in? The second one, right here. So that's theta. That's 145. So identify the quadrant Q2. Just because we need practice with it, and that's what the second section is going to ask us to do anyway, what is the reference angle of this? Let me go with Kaylee Smith. What is the angle between the terminal ray and the x-axis? 35. In your calculator, you could just subtract 180 minus 145 to find this difference here, which is a 35 degree reference angle. Reference angles always between 0 and 90. Okay? Go ahead and draw 320 on your own. Let's see how we do there. And you, on your own, tell me the quadrant and the reference angle as well. Aiden, what quadrant do you think? 4. Very good. So it opens all the way around to 320. Do you know the reference angle, Aiden? Very good. Because this is 360. The full circle would be 360. So the reference angle between the terminal ray and your x-axis is right in here. Your reference equals 40 degrees. That's the difference between 320 and 360 there. Very good. Part C. Now this is a first quadrant angle. 72 degrees is just right here. When you're a first quadrant angle and you're already between 0 and 90, your reference angle is the same thing. So your reference angle here is just also going to be 72. Let's jump down to G, the 460. It's over 360, right? How much over 360? 100. So you're going to go around a full circle to get your 360, and then an additional 100 is going to land you just past the 90, right? Didn't we go 10 degrees past that? Most importantly, though, what's our reference angle? How far is this? 80. Awesome. Now, if you wanted to do that a different way, you could do 0, 90, 180, 270, 360. This is also 450. Add another 90. This is also 540. You could do the difference between the 460, where that left off, and the 540, which is your next x-axis read. Okay? Any questions on that? All right. Andrew's going to hand out homework. Please. I'm going to hand out your, oh, maybe someone else can help me, your exponents test. Corrections are due, tell me, Wednesday. Yes. It's just like X, Y, and Z. It's just we're talking in Greek letters, so no.